So we're going to get started, and those of you on the other end of this, make sure you have your algebra tiles because we're going to be using those, the ones that you should have printed off and cut out. For the rest of us, we have some here, and we're going to be actually using them to not play today, but to build. And so here's our essential question for today. And last week we talked about the essential question being how is multiplying the monomial times binomial similar to finding the area. And this time we're going to compare and contrast multiplying that monomial by a binomial to how we multiply binomials by binomials and binomials times trinomials and trinomials times trinomials, which is what we're going to look at today. So on the other end, if when you get this done, then go ahead and give me a check. Okay, looks like the other end is ready to move on, and looks like just about everybody. I'll come back to this at the end. So, okay, just remind me so I don't forget, because I know I'll forget. Okay, so let's clear this. All right, so last week we multiplied a monomial times a binomial. We also did the adding and subtracting piece, but we're going to focus on the multiplying piece today. And so, as a review, let's get those algebra tiles out and let's build that. That's a good question. So the question was, which ones are the x's, which ones are the ones, which ones are the x squareds, or what are they all called? So what do you guys remember about that before we get started? Which one's the x squared? Anybody remember? The big square. Why is the big square x squared? Let's refresh our memory on that. Why? Let's start with the small one. What was the small one called? 1. Why? How long is this side? Yeah, one side was 1. It's a square, so the other side has to be 1. when I find the area, I multiply the length and the width, right? And I get a 1, so I'm going to call it by its area name. If this is 1, how long was how long was, I gotta do it, you guys can see on the other end, how long is this side right here? It's 1, right? Excellent job, Philip. Okay, so, oops. There we go. And how long was the other side? X. Okay, so to find the, we called this by its area name, so what would the area of this be? X. Okay, and so how long is this side right here? X. Good. And so if this is X and this is X, this side would have to be X also because it's a square. So the area would be X squared. You guys need to write that down again so you have it in front of you. Great, do that, okay? And then start working on building. You can know how to build that particular problem. And for those of you on the other side building this with your algebra tiles, then just make sure you mark one side with the negative sign so you know which side is negative, which side is positive as you're working. So this is going to, okay, so okay, okay. So this is, negative the X's or the ones or what? All right. Looks like most of it you're not telling okay. I'll try to do a few more for seconds. I appreciate you guys sharing for right now. All right, so when you build this, and I'm going to turn the camera on, so on this end, the other end, you can see what we're doing. And this. So on this end, negative 3x on one side. Some of you did it on this side, some of you did it on this side. Does it make a difference? No, it doesn't. You're still going to get the same result. It just looks a little bit different because it's just turned, isn't it? Okay, so put 3x's there. And then the other side was negative 2x, and then it said minus 4, right? There we go. So negative 2x. I put 2 x's up here. And then I put 1, 2, 3, 4 ones. And then I built what was inside here. And so remember, if I have a negative times a negative, I'm going to end up with a positive, right? If I have a negative times a negative, I end up with a positive. So I have 3 of those. And I've got a second row here. So I've got positive, positive, positive. And so I've got a whole section of x squared, don't I? Okay? Now what goes here? X is a length of 1 by a length of x, right? And again, it looks like I see negative times negative, so I need to put a bunch of positives. So I've got 1, 2, 3. Okay, so I'm putting a bunch of positives in here. So as I did that, what did we get as an answer? Okay, so that equals positive 6x squared, because there's 6 of those x squareds, right? And then there's 12 positive, 12 plus 12, or just like that. Is that okay with that? I keep some head shaking. Oh, why do we need the x? Yeah, that's what that's called, isn't it? These are called x's, right? There's 12 of these x's there, so we have to say 12x. Okay? Now, so we built this using the algebra tiles, and we didn't count the red part because that was just our frame, wasn't it? We just counted the part inside here. And you'll notice again, you've got your x squared up here, and you've got your x down here, so there's like 2 parts to this, isn't there? Okay? And so we're going to actually draw this another way so that if we get to place at the point where we don't have enough of these to build it, or we've got a couple different variables, then we have a way to actually work that out if we can't do it with the algebra tiles. Because at some point we're not going to be able to use the algebra tiles to do this, right? So we're going to build what's called a generic rectangle. And my generic rectangle, we did this kind of a little bit last week. Why did I divide that into 2 parts? Okay, so let's stop and think about that. What does our 3x represent in terms of my rectangle shape? What does this represent in terms of the rectangle? What is it? It's my, here's my rectangle. What does this represent? The length of the side. Excellent. That's what you said the answer there. Good. This is the length of one side. This is the length of the other side. This has one part that's all the same. This has two different parts, doesn't it? That make a whole part, right? The whole length. I've got the x's and I've got the ones, which have two separate parts to make the entire side. So that's why I have two parts here. I've got one part and I've got two parts because how many parts are here? How many terms? I've got one term, two terms. I have a binomial. Remember, bi means two, right? Like bicycle. So I needed two parts here. Okay? So I'm going to actually use this to help me figure this out. The negative on there, negative 3x. And that's kind of like representing this side up here, isn't it? Okay? And this side would be negative 2x for this section. Oops. And this section over here would be minus 4 part. Okay? I could have written it so that the picture went up and down this way, couldn't I? So it matches what I built up here. It could have gone that way, right? That make sense? And so it would go on the top. The negative 3x would go on the top. And the side down here would be the negative 2x and the negative, minus 4. Okay? So when I'm actually, if I'm finding the area of the shape, I can find the area of the two parts, right? I can find the area of that part, and I can find the area of that part. And I can see that up here in the picture. 3x times 2x makes, negative times negative is positive. So negative 3x times negative 2x makes positive 6x. And you can see that in the picture. So that's exactly what I'm going to write in that space. Is 6x, actually it's 6x squared, 6x squared. And what goes in this one? In the other box? Yeah, 12x, and it's a positive 12x. So once I've got it here, then I just write it like I did. I have to write it like I did right here, and I'm done. Okay? So I can build it. I can generalize it in a generic rectangle. Let me write that name on there for you because that's important so you know what that means when I say that. Okay, so it's a generic rectangle. Mix my T and my A together a little bit there. All right. Make sense? That's pretty easy. Are you glad it's easy? All right. So let's make it a little more challenging for you. I think you need that challenge. All right. So let's go to this one. Okay. Based on what we already know, how are we going to multiply that? Build it. Think about if we build it, what would your generic rectangle look like? Make sure you put it back in the right packet. All right, so most of you are doing a great job with that. And I'm going to take this down. We're going to rebuild. Okay, so we have X on one side, and we have 4X's on the other side. And you can go either way you want. It doesn't make a difference. And then we've got to put some plus ones up there too, right? Put some ones. We've got 5 on one side, and then we need 2 on the other side. Okay, so we got 2 here. It's going to be in the way for those pieces. We got 2 here, and we need 5 here. And we have 2 down here. So we're going to build positive times positive, so these are going to be positive. And most of you got that. What got a little tricky is when we had to start putting all these positives on here, right? And most of you did a great job putting these on. How many of these X's are we going to need in this section here? Why? How long is this? 5 times 4. So I would need 20 of these, wouldn't I? Okay. So we're going to say we built that all out. I'm going to move these down here because we need 5s and 5s and 5s and 5, right? We have 4 sets of 5. Now, am I done? What do I put here? More what? So a bunch of 1s right here? Everybody okay with that? So I'm going to go in first. Let's see. Well, that's not going to work because that's longer than that. So what would go here? How long is, because this side is 1 and this side is X, right? So we'll hold on to those. So we need a couple X's here. But I think you're right, we would need to, what do we need to put here? The 1s need to go here. I need to fill all that in. How many 1s will I need to put there? 10, because it's 5 by 2. And so that's exactly what we would do for our generic rectangle as well. So what I'd like you guys to do is I'd like you, what would our generic rectangle look like? Think about that. Talk about it at your group. What would our generic rectangle look like? We do the last one. You're going to find only one on there. So one side goes on the one, the other side goes on the 2, right? There's 2 parts. So there's 1 part, there's 1 part. Look at your picture times D. How many parts does your picture have? You've already the standard. Excellent. All right, so most of you did reason through the that it's going to have 4 parts. So what are those 4 parts going to be? Remember, one side would be 4x plus 2, because that 4x plus 2 is like our length on our rectangle, isn't it? So how many parts does that have? It has 2 terms, doesn't it? So because it has 2 terms, I need to draw the line this way. How about the other side? Yeah, it has 2 terms also. There's the x and the 5. And so you're going to divide it this way also, instead of doing all lines in one direction. Okay? We're going to talk about that in just a second. Why that, when you do it kind of all the same way, and then you have to do it this way. But part of it is because, like we said, that 4x plus 2 is like your length, isn't it? And your x plus 5 is like your width. So you have to put one on one side of the rectangle and the other on the other side of the rectangle. Then when you multiply it out, you get 4x squared. Most of you saw that, and you can see that in the picture, right? And then we saw it here. We said there was going to be 20 x's here, right? Yeah. And down here, we said there was going to be 10 of those ones, wasn't there? And you can see that there's a 2. You can see the 2 times the 5 that we talked about, can't you? Okay? And the 2 times 5 makes positive 10. Oops. And so what goes in that upper corner? 2x, because I have a 2. This square or rectangle has a 2 as the one length and an x as the other length, so it's going to be 2x. So all together, if we multiply that out, what do we get? For x squared, yeah, plus 22x, because I have to add the 2 places where the x's are, don't I? So you can see that the x's are split in 2 different places, aren't they? Okay? And then plus 10. All right? Does that make sense? Okay, and you can see how the items are getting split in terms of your x's, and with these 2 have their own spot. Okay, the x's get 2 spots in there, in that rectangle, generic rectangle, and the x squareds get 1, and the 1's get 1 spot. All right? All right, so let's try another one. You guys choose which way you want to do it. You can build it, or you can use your generic rectangle. We can build, so we can do different things first, we go back and build it and verify I did it right, which is fine. So here you go. So the exact page number is about the rectangle, yeah, I can type it out. It's showing you the longer you do it, and then I'm showing you the shape, getting you to make a connection to what it's starting to do faster. Okay, so most of you guys did a great job with this, and some of you went straight to this, and you noticed that there was 2 parts by 2 parts, and you built this. And in your picture, if you used the algebra tiles, can you see your 2 parts and your 2 parts? So we have 3x minus 2. Did it make a difference if I put it on this side or not? Okay, could I put it on the other side? Okay, yeah, could have. Good. And I've got negative x minus 4 here. So what kind of shapes are going to go in this section right here? The squares, right, the x squared. So how many x squares am I going to need? How do we know that? If I'm finding the area of that first square, what's the length? 3 what? 3x, what's the width? Okay, negative x. So negative x times 3x would be negative 3x squared. And those of you that built it, is that what you got for that section? 3 negative x's, x squared? And you built it, is that what you got? Okay. What about the next section? If I move over to here, what kind of shape am I going to get in that section? X's, how many? Yeah, because, and I can see that here because negative 2 times negative x makes positive 2x. Yeah, I heard somebody over there say that. Excellent. Okay, what about the next square, or next box? What goes in the next box down here at the bottom? This one right here. X's. And how many X's? Let's see, the length is negative 4, the width is 3x. So how many X's do I need? How do you find area, Philip? So what you said that what's going in this box? You said the X's are going in this box right there, right? How many X's do you have in that section? How many X's in that section? You're counting the right spot. You didn't count your entire section there though. Let's think about that. How do you find area of a rectangle? Multiply. We're going to multiply our length times our width. So if I multiply the 3x times the negative 4, what do I get? What's 3 times 4? Okay, it'll be negative what? Are you adding or are you multiplying? Okay. Let's multiply now. Because that's what you told me to do, right? Okay. That's okay, we can figure it out. You have 3, 6. Is that 3 more than 6 is? And then 3 more than that is? 12. Okay. So 3 times 4 is 12. And that's what, see how you can figure that out? It's no big deal. All right. So, get the marker here. So this is going to be negative 12x. And then the last box, Alondra, what are we going to get there? 8. Yeah, it's a positive 8 too, isn't it? It's negative times negative. So my final result here is going to be negative 3x squared. And remember, you have to kind of go back and write it out, because the other one's just a tool to get me there. And how many x's do we have? Well, we've got 12 negative x's and 2 positive x's. So what does that do me? Yeah, negative 10x. And plus 8. All right? Okay. So, I'm going to skip. What would you do here? What is that telling me? Yeah, so if you don't build it, but if you're going to build it, it would be 2x plus 3 times 2x plus 3, because it's a square, and we know it's a square because it says squared on it, doesn't it? The exponent tells me it's a square, doesn't it? Okay? So, we're going to come back to that. What would you do? I'm going to skip that. Can you see why we need to know how to do the generic rectangle? Because we can't build that with our algebra calc, can we? Right? But if we know how to use the generic rectangle, how we're multiplying all the parts, we can do that problem, can't we? Okay? So I'm more worried at this point about this one. How would you build that one in a generic rectangle? Do it. Try it. See if you can figure it out. Alright, so let's just make sure we have the generic rectangle the right way. Most of you are getting the multiplication and stuff in there. So I'm going to draw a little bit longer one this time. On one side, I'm going to have the x plus 5. That means I need, since it's a binomial, I need 2 parts, right? Because there's 2 parts on the two terms in the problem. And then up here, I'm going to need 2x squared minus 3x plus 4. And then, so that's a trinomial, so I need 3 parts. And then I multiply it out and get the answer, and then write the answer out. What if I get a trinomial times a trinomial? How many parts on one side do we have to have? Trinomial we need 3 parts. And that's what this right here, right? So that's times another trinomial. How many parts would you need on the other side? 3. So all you really have to do 9 multiplication first, right? Okay, so what I'm going to do is essentially clean up, okay, and just making sure things are neat, tight, and there so they come in. And then summarize quickly what we do. How do we multiply? When we're doing this, we multiply. What do we do? We take this part here, right, times this part here. So to summarize what we're going to do is, in terms of how do we multiply using our generic rectangle. Okay. Okay. Yeah, no, that's fine. Yeah. Okay, so we wrapped up this lesson. Make sure you summarize what you do for this, and then if you want to stick around, that's fine. If you want to go, that's fine too.